Man is in love. How do I know? He came and walked with me, and he told me so. In a song he sang, and then I knew a man is in love with you.
Section 6.1 is review from last year. We'll do it in two parts. Part 1 is going to be about graphing lines, and boy did we spend a lot of time with this last year. So I know it's been a long summer, but I'm hoping a lot of this will come back to you. So we're going to graph some lines. The first line we're going to graph has the equation y equals 2/3 x plus 6. And this here, this form, because there's different forms of the equations of line, this is in slope-intercept form. I'm not sure if you remember this, but this is kind of our favorite form when we're actually graphing the lines, because it's so fast to graph them when they're in slope-intercept form. And what slope-intercept form looks like, if you don't remember, it looks like y equals mx plus b, where m equals the slope, or is the slope, I guess I should say, and b is the y-intercept. And the other thing I guess we remember is slope is equal to rise over run. Okay, so with that in mind, if we look at this, y equals 2/3 x plus 6, 2/3 is the slope, right? The number right in front of the x is the slope, so 2/3 is the slope. And the 6, or positive 6, is the y-intercept. So we can graph this thing right away. What do we graph first, the slope or the y-intercept? We graph the y-intercept. What's a y-intercept? It's where it crosses, it's where the line crosses the y-axis. This is the y-axis, the vertical axis of the y-axis. So we're asking, where is 6? Where's the y-intercept of 6? It'd be right here. And then from that point, we're going to move with a slope of 2/3. Remember, slope is rise over run. So we're going to rise 2 and we're going to run 3. Starting at this point, don't start down here. You start from this point. So rise 2, 1, 2, and run 3. 1, 2, 3. You can do it again if you want. Rise 2, run 3. 1, 2, 3. Remember, you could have also gone the other way. You could have gone down to 2, risen -2. That's a negative move. And run -3 to the left 3. Because two negatives, negative going down, negative to the left, two negatives make a positive. And that's what we want here. We want a positive slope, right? 2/3 is a positive number. Not negative 2/3, it's just 2/3. And if I join these points together, you will definitely get a positive slope. That's all I have to do here is join these together, and I have my line. Boom, done. Got an arrow on this end, put an arrow on that end. Finished. Let's go to the next one. Y equals -3x. This is also in slope-intercept form. It's also in y equals mx plus b. What's the slope in this case? The slope is -3. What's the y-intercept? I don't see anything out here. But there is still a y-intercept. What number could you put there? You could put plus 0. Since there's nothing there, you could put plus 0. So this is the y-intercept. So the y-intercept 0. Where does that mean it crosses the y-axis? Right here. And the slope is -3. But remember, we like to think of our slopes as fractions. So rather than thinking of it as -3, why don't you think of it as -3 over 1? Okay, good. So now we're going to start at that point, the y-intercept, where we start there, and we move -3, that's 3 down, 1, 2, 3, and 1 to the right. We run 1. And we can do it again, down 3, 1 to the right. You can do as many times as you want, like that. You could also, starting from this point, have gone up 3, that's a positive move, and then 1 to the left, which is a negative move. Positive and a negative make a negative. And that's what we want here, right? We want a negative slope. Yes, this will make a negative slope. So all I have to do is draw the line. And there it is. We're going pretty fast here. Next one, y equals 4. Alright, there's two ways to think of this. You could definitely think of this as being in slope-intercept form, y equals mx plus b. So if that's the case, what's the slope, y equals 4? What number is right in front of the x? Well, I don't see an x. So that means if you don't see an x, there must be how many x's? No x's. It's kind of like this. This is another way of writing this equation here. So the slope is 0. And the y-intercept is, I'll just put int for intercept. The y-intercept is 4. So no problem. We can put our y-intercept of 4 And now you have to remember, what does the slope of 0 look like? You might not remember this. So, I'll tell you what, before we do that, I'll show you the other way you could solve this. You could graph this. The other way you could always, if you ever get confused, remember you can always make a t-table, x, y. Now, if y equals 4, it doesn't matter what x is equal to. Y is always equal to 4. That's what this says. Y is 4, 4, 4. So it doesn't matter what numbers you put in here for x, y is always equal to 4. Put some numbers in here. How about easy numbers? 0, 2, let's put a negative number in. Negative 1, whatever. 0, 4, we can graph that point. Hey, look, we already did graph that point. 2, 4. Well, that would be out here at 2 and up 4 right there. Negative 1, 4. Negative 1, 4. Do you see that if y equals 4, we're interested in all the points that have a y value of 4? All these points I'm putting dots on here, even, here, all these, they all have a y value of 4. So what the graph will look like is like this. It's just a horizontal line. Now, we gave you a memory device how to remember this, because remember, some slopes are 0 and some slopes are undefined or no slope. And the way I said you could remember this is, if you have a horizontal line, you can easily turn that into a z for 0. So that's how you remember that a horizontal line has 0 slope. If you have a vertical line, you can turn that into an n for no slope, or you could also turn that vertical line, not quite as nicely, but you could turn that into a u for undefined. So those are your memory devices there. If it's y equals whatever number it says, it's always going to be a horizontal line. If it was y equals -2, boom, right here. If it's y equals 7.5, go up to 7.5, and it would be right, that's not a half, but you know what I mean, right in there. So anytime it says y equals something, it's a horizontal line. Guess what's going to happen when it says x equals something? Yes, you guessed it, it's going to be a vertical line. But let's slow down a bit here. First of all, this is not in slope-intercept form, because slope-intercept form we want like this, y equals mx plus b, we want the y by itself, and I don't even see a y here. So this is not in that form. So you'd have two ways to solve this. I mean, you probably would just get to the point where you know that this is a vertical line. But if you didn't, one way you could solve it is by making a t-table. It says x equals -5. So no matter what point you're talking about, x is always equal to -5. Doesn't matter what y is, whether y is 0 or y is 6 or y is -2.5. I don't know why you would use that number, but it'll still work. -5, 0, -5, 0, right there. -5, 6, -5, 6 is right there. -5, -2.5, -5, and -2.5. Do you see that all these points I'm drawing here all have an x value of -5? And that's what we're looking for, all the points that have an x value of -5. All you have to do is draw the line like that. Anytime you have x equals a certain number, it's always going to be a vertical line, an undefined slope. Okay, next one, 2x minus 3y equals 12. Alright, we did this type last year. This is the second type we learned about last year. This is called standard form. And with standard form, the way that looks is ax plus by equals c. And what you should remember about this, or I'll remind you about, is the a must be positive. Or 0, I guess. I'll say, can't be negative. Let's just say that. The a can't be negative. It can be 0 or it can be positive. And the other thing we need to remember is with the a, the b, and the c, no fractions and no decimals. They have to be integers, or in the case of the a here, it has to be a whole number. Okay, how do we graph these? Well, you have, I would say, two main ways you could graph them. One way is you could turn this into y equals mx plus b. So if you wanted to turn this into y equals mx plus b, your goal is to get the y by itself. And you also want y to be positive. So what I would probably do is take this -3y and move it over to the other side. So that would give you 2x equals, if I take -3y and move it to the other side, it becomes positive 3y, and I still have a plus 12 here. But I don't want the plus 12 on the side. I want the y by itself. So let's take the plus 12 and move that to the other side. So now I have 2x, plus 12 comes to the other side and becomes -12 equals 3y. And I want y by itself. This is 3 times y, so I'm going to have to divide this side by 3 and divide both things on this side by 3. So what that will give me is 2x over 3. I can't really put that in simplest terms. I'll just leave it like that. 2 over 3x, or 2/3 x. Negative 12 divided by 3, that's negative 4. And the 3's here cancel. You're just left with y. I could put equals y, or I could also write the y out front here. Great, now we're back to a question like we did on the other side of the page. It's in slope-intercept form. What's my y-intercept? Negative 4. The y-intercept is negative 4. And my slope is 2 over 3. Rise 2, run 3. 1, 2, 3. Rise 2, run 3. 1, 2, 3. Rise 2, run 3. 1, 2, 3, etc. And then I could draw the line, and I'll do that in a second. The second way, and I think this is probably what most of you would have done if you're graphing this one, is you wouldn't switch this. It's kind of a lot of work to switch this into slope-intercept form. So what you probably did instead, I taught you this last year, is you might put it in a t-table. And remember what we're going to look for is we're going to look for the x-intercepts and the y-intercepts. So a quick reminder, what's true about every single x-intercept? Wherever I draw these points, if I was to name these points, what do they all have in common? Well, this point here, don't write all this, but this point here is negative 2, 0, and this point here is negative 4, 0, and this point here is negative, how about this point right there, negative 7.50. What's true about all these points? They all have a y value of 0. So if you're looking for an x-intercept, what you're interested in is when y is 0, what's x? So let's figure that out. If y is 0, if I put 0 in there, I'd have 2x. Take away 3 times 0 is just 0. This is just gone. It's not even there anymore. So all I have to solve is 2 times what equals 12? 2 times 6 equals 12. So the x-intercept is 6. 6, 0 is my point. Yep, I have that point right there. Right? Now, similarly for the y-intercept, what's true about all the points on the y-axis, all the y-intercepts here? Let's name some of these points. This point is not 10, 0. It's 0, 10. This is 0, 8. This is 0, 4. This is 0, 5.75, or I don't know what that is. Anyway, the point is that on the y-axis, all the x values are 0. So if you want to know what the y-intercept is, you're interested in when the x is 0, what does y equal? So let's try it. Let's put 0 in here. 2 times 0 is 0. That's not there anymore. But notice there is a negative sign right here. It's negative 3 times what equals 12? If you want, divide both sides by negative 3, or you might be able to just figure it out. The answer is negative 4. So my y-intercept should be at negative 4. The point is 0, negative 4. And yes, that's exactly where it is. So either way will work, but mostly last year what we used is this method of x-intercepts and y-intercepts, and it's very important. Okay, let's graph this. Boom, done. Next one. I don't think I actually named this last year. Maybe I did once. I didn't make a big deal about it. It's not a big deal, I suppose, but I should have actually spent a little more time with it. This is called general form. And it's almost exactly the same as standard form. What's the only thing different? The only thing different is the c value is not on the right-hand side of the equal sign like up here, it's on the left-hand side. That's literally the only thing different. So the form would be ax plus by plus c equals 0. And just like up above, it's the same restrictions. This can't be negative, the a value can't be negative. And the a, the b, and the c, no fractions, no decimals. I'm going to write really fast, but just look up above. It's exactly the same thing. So how would you graph this? I would say it exactly the same way as what I said up above. You could switch this into y equals mx plus b form. If you want, I'll do that really fast, but I'm going to do it quickly here. I'm going to leave the 5y on this side because it's positive, and I'm going to move both of these things over to the other side. So my 2x would become negative 2x, and my plus 15 would become minus 15. Now I want to get the y by itself, so I need to divide by 5 and divide all these by 5 too. And what I'm left with when I do that is y equals negative 2 over 5x. 15 divided by 5 is 3, so take away 3. And now I could graph this. Y-intercept is negative 3, and the slope is negative 2 over 5. That means go down 2 and over 5. And I'll do it once more. Down 2 and over 5. Like that. Okay, the other way you could do it is exactly what we did before with the t-table. But the first thing I would do before I do the t-table, I'll draw it here, is I would change the general form equation that we started with, I would change it into standard form. Well, that's about the easiest change of all, because if you need to change it into standard form, all you have to do is take that c value and move it to the other side. So in standard form, which I'll write over here, it'd be 2x plus 5y equals 15 comes over, negative 15. Okay, now we're going to find x-intercepts and y-intercepts. To find x-intercept, you put 0 into the y. So if I put 0 in here, 5 times 0 is 0, that's just gone. So all I'm wondering is 2x equals negative 15. 2 times what equals negative 15? You could divide both sides by 2, you get negative 7.5. I know that's disturbing to get a decimal, but it will work, don't worry. Your intercepts can be decimals. I'm not saying when it says no fractions or decimals, it doesn't mean that the intercepts can't be decimals. It means that the values in the equation can't be decimals. Okay, to get the y-intercept, we want to put a 0 in for the x. 0 in here. 2 times 0 is 0. This is gone. So all I'm wondering is 5 times what equals negative 15? Or divide both by 5. You get negative 3. Okay, so the y-intercept which we just did is 0, negative 3, and there it is already. And the x-intercept is negative 7.5, 0. Negative 7.5 is right there. 0. And yet that looks like it makes a perfect line, and I shall draw that line right now. If only you could draw lines as quickly as I could, eh? I know, it's a gift. Just as a last reminder, there is one more form. I'll put it down here. It's called point-slope form. I don't think you need to know it at all in this course, but just for curiosity's sake, remember it's y minus y1 equals mx minus x1, and this is the slope right here, and there's one other point you can get out of this, and the point is at x1, y1, and this is the one where you took the opposites of the number. So if it was y minus 2 equals 1/2 x plus 3, you know your slope is 1/2, and what's the point it goes through? It doesn't go through 3, negative 2, it goes through negative 3, positive 2. And I'm not going to spend time right now explaining why it's the opposites and blah blah blah, because you don't really even need to know that at all this year. Okay, we're done. I know that was fast and furious, but it should be mostly review. Very, very important though that you get this. If you have any troubles, please come and see me. Alright, take care.
A man is in love. How did I guess? I figured it out while he was watching you dress. He'd give you his all if you but agree. A man is in love and he's me.